Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. How dangerous is exposure to extreme cold or warm weather conditions? The answer is very dangerous. Every year, approximately 500,000 people dies due to prolonged exposure to high or low temperatures. For example, during heat waves, cold spells, and other extreme temperature weather conditions. This is more fatalities than associated with hurricanes, tornadoes, hail, lightning strikes, and so on. Our body produces heat naturally, and then that heat is lost to the environment. The rate of heat production by our body and the rate of loss of that heat to the atmosphere determines our body temperature. And normal internal body temperature is around 37 degrees Celsius. Now, our skin and tissues right next to the skin and limbs can have lower temperature, but core temperature and temperature of vital organs needs to stay around 37 degrees Celsius. Now, heat in our bodies is produced as a byproduct of cellular activities when molecules such as glucose are broken down in our cells. And that chemical reaction releases heat. And that heat is used to warm our body. The heat is then from the cell that is producing it also transported throughout the body via bloodstream. The biggest producers of heat in our body are muscles, brain, and liver. And this process of our body producing heat is known as thermogenesis. If the temperature of the air, of the atmosphere, is higher than the temperature of our body, which is not so common, then we gain heat from the atmosphere. If the temperature of the air is lower than the temperature of our body, which is more common situation, then we are losing heat to the environment. The processes responsible for gain or loss, which is more common, of heat are radiation, conduction and convection, and evaporative cooling. During daytime, when we have sunshine, the exposed skin is absorbing shortwave solar radiation, and the absorbed radiation is then transformed into heat. That heat warms our body. Now, the absorption can also include the absorption of ultraviolet radiation, which can be extremely harmful, but I have a completely separate video discussing about negative effects of ultraviolet radiation. Now, at the same time, our body also both absorbs and radiates in the long wave part of the spectrum, the so-called infrared radiation. During day, when we have sunshine, absorption of short wave and long wave radiation are larger than the loss of the heat through the emission of infrared radiation. During night, however, when there is no sunshine, the loss of heat through the infrared radiation can be substantial. Conduction and convection work together to transfer heat either to or from our body. Most commonly, it is from our body. If the temperature of our body is larger than the air temperature, the heat from our body is first conducted and then convected into the air. I have entire videos on conduction and convection processes, and as you know, convection is the dominant process and much more important process, and that's why I emphasize so much on it in my previous video on wind chill. The next process is evaporative cooling. It is a phase change of liquid water to water vapor, and that process requires energy. When water is evaporating from our skin, the heat that is required for evaporation is taken from our skin, and therefore we feel colder. The more water we have on our skin, the more will evaporate and more energy will be taken from our skin, therefore we will feel colder. And you know that. You know that because every time you leave swimming pool, even on a hot sunny day, you feel a little bit cold in next few seconds up to approximately 1 minute. Why is that the case? That's the case because water from your skin is evaporating, and energy for that evaporation is taken from your skin. Now, during summer, it's not a problem. Everything will evaporate in a few seconds, and then the sun will shine and warm your skin, and life is good. But that process can be fatal during cold temperature when the heat loss through this evaporative cooling can be extensive. Now, our skin always evaporates a little bit of water. And that is because deeper tissues in our skin always diffuse a little bit of water to the skin surface, and then that small amount of liquid water almost instantaneously evaporates. And we do not even feel it, and our skin does not feel wet. This process is called insensible perspiration. We cannot feel it. However, there is also sensible perspiration, and that is sweat on our skin that we can feel. What is sweat? It's a dilute solution of water and various salts in our body. Men are homeothermic creatures, which means that our internal body temperature does not change much. In fact, it does not change more than 2 degrees Celsius above or below 37 degrees Celsius. And fortunately, our body has a series of mechanisms to regulate body temperature, and that process is known as thermoregulation. By internal body temperature, I mean temperature of our vital organs, which in this context are brain, heart, lungs, kidneys, and digestive tract. If the temperature of these organs deviates more than approximately 2 degrees Celsius from 37 degrees Celsius, then those organs do not work properly. Serious damage can be inflicted to the organs, and ultimately the person can die. It is absolutely amazing that the air temperature outside can have such a huge fluctuations, and yet our core temperature stays pretty much unchanged. How does our body deal with mild temperature variations? When the air temperature is in the interval between 20 and 24 degrees Celsius, then grown person fully clothed feels comfortable, particularly indoors. And this is my situation now. The temperature in this room is approximately 23 degrees Celsius. I am dressed and I feel good. One of the reasons is that I have clothes, and these clothes trap air between my skin and the fabric. And this air is warmer than the air in the room. It's warmer because my skin warmed it, my body warmed it, and clothes prevent loss of heat through the processes of convection and conduction that I just discussed, particularly through the process of convection, which is very important because I said convection is more efficient at removing heat than conduction. Now, clearly, it depends what type of clothes you have. If you have clothes with many layers, that means you will have many layers of trapped air between your body and the ambient atmosphere, and that will significantly prevent loss of heat. You will feel warmer. Some materials are very good insulators. For example, wool is very good insulator, so you will feel very warm in wool. Some other types of clothes are very good, for example, at reflecting radiation, like bright white clothes. They reflect solar radiation. Dark clothes absorb radiation, making you feel warmer. If the temperature is very high and you are on a sunny day outside, then you should have loose clothes. That's because loose clothes blocks direct solar radiation, but yet it is loose, so it enables ventilation through the process of heat convection. What about if air temperature drops below 20 degrees Celsius? In that case, the heat loss can be substantial. And if the brain detects that the heat loss is extensive, it will take actions. to prevent further heat loss and maintain constant temperature of vital organs. The first measure that the brain takes is a very obvious one, but it should not be taken for granted. And that first obvious one is a consequence of evolution. The brain, if it is very cold, tells us, go inside, light a fire, increase heat, dress better, and so on. Did you ever think about it? You don't have to finish absolutely any school and know nothing about atmospheric sciences or physics or anything to know that you should dress up better in winter. How do you know that? You know that because all people before you did the same. How did they know it? It's just evolutionary consequence. People that didn't dress up properly, they probably died to severe cold. So that's the first reaction of our brain to substantial heat loss. The next mechanism in line to prevent further temperature drop is for our body to produce more heat. This happens when the brain sends a signal to our biggest heat producers, the muscles, as I said earlier, to start working and produce more heat. As a consequence, muscles start contracting rapidly in the process that we know as shivering. There can be 15 to 20 contractions per second, which results in substantial heat production increase. 4 to 5 times more heat is produced by our body when we are shivering than during the normal conditions. Yet another process that our body uses to combat heat loss is goosebumps. This is primarily directed to reduce heat loss through conduction and convection. Here, the brain again sends signal to small muscles under the skin to lift those hairs on the skin, and that thickens the boundary layer around our skin. As I discussed in my previous video, boundary layer is a buffer zone of few millimeters between the skin and the rest of the atmosphere, and that boundary layer is much warmer than the rest of the atmosphere, and because of that it reduces the heat loss through the processes of convection and conduction. The next and the last mechanism that our body uses to maintain constant inner temperature is to prevent further heat loss. In simple words, at some point our brain realizes it is fighting a losing battle and our body simply cannot warm up entire atmosphere. We are losing much more heat than we are producing, and the brain says enough is enough, and it directs blood vessels in our extremities and limbs to constrict, thereby preventing blood flow into those regions of our body. When that happens, those regions become colder, particularly skin becomes very cold, and when the skin becomes very cold, it approaches temperature of the air, and because of that, the heat loss is reduced. Now, unfortunately, this might end up causing you frostbites or severe damage to your skin, but from the point of view of your brain and your survival, that is better price to pay than having temperature of vital organs dropping below 35 degrees Celsius, which can ultimately cause your death. Now, the further the temperature drops, more blood vessels will be constricted and colder you will feel. All that blood that does not go to your extremities goes into your vital organs and core of your body, trying to maintain the constant air temperature. However, sometimes that is not enough. What happens then? If the core temperature drops below 35 degrees Celsius, the person is in serious trouble. The person entered the stage of hypothermia. The first stage of hypothermia is characterized by uncontrollable shivering. That is followed by person being apathic and lethargic. And if the core temperature drops below 32 degrees Celsius, then it gets even worse, of course. In that case, the shivering eventually stops, the muscles become rigid, and the person becomes unresponsive. It cannot help anymore himself or herself. I'm sorry about that. Chuche-chan. Lastly, if the temperature drops below 30 degrees Celsius, the person becomes unresponsive and loses consciousness. If the core temperature goes below 24 degrees Celsius, death occurs. The lowest temperature from which a person was able to recover was 16 degrees Celsius. So the next question is, how can we help a person that entered the state of hypothermia? If the core temperature falls below 29 degrees Celsius, the process of thermogenesis becomes ineffective. That means our body can no longer effectively produce heat. And the person, of course, which is in hypothermia, in that case requires help. The help should focus on preventing further heat loss and supplying heat to the person. Hypothermia often happens in winter season if a person falls in very cold water. After the person is rescued from the water, those wet clothes should be replaced for dry clothes. That's because we don't want that cold water and moisture to evaporate from person's skin, further decreasing body temperature. Also, water has very high heat capacity, as I discussed in previous videos, which means it will take a lot of heat from our body to increase temperature of that water just a little bit. For all these reasons, replace those wet clothes for dry clothes whenever possible. After that, the person should be taken indoors, the heating should be increased, and so on, all these logical steps. If that is not possible, it is very beneficial to hug the person that is suffering from hypothermia, because our body emits a lot of heat, approximately 100 joules per second, 100 watts. And that is a substantial source of heat, approximately one light bulb. And that heat helps the other person recover from hypothermia. Medical help should be called whenever possible, of course. If the person is suffering from hypothermia, it is advantageous to lift them from the ground, because we want to minimize the heat loss through conduction to the ground. And of course, it is very beneficial to give warm beverages, non-alcoholic warm beverages to the person suffering from hypothermia, because that will warm their core from within. In that case, one should never give hot beverages, but warm non-alcoholic beverages. It is sometimes believed that alcohol is good in these situations, but that is not the case. First of all, alcohol numbs muscles and prevents shivering, and as I discussed, that is source of additional heat for our body. Alcohol also opens blood vessels and enables blood to go into extremities, and that increases heat loss, as I discussed a few minutes ago, because brain purposely wants to close those blood vessels to prevent heat loss. And also, if the person is intoxicated, then the judgment and decision making is not best, and the person quite often does not feel threatened, and in these situations that can be fatal. We saw what happens if the core temperature drops below 35 degrees Celsius. But what if it increases above 39 degrees Celsius? In that case, the person suffers from hyperthermia, also dangerous and potentially fatal condition. Hyperthermia has two stages. In stage number 1, known as heat exhaustion, the person first suffers from very uncontrollable sweating, then it starts vomiting, and overall feels very, very weak to the point it cannot do any normal activity. This usually happens if the person is exposed for a long time to intense sunshine. To help the person in trouble, They should be brought indoors, their clothes should be removed, they should be ventilated by a fan. It helps a lot if they are sponged with water, and it is also very important to give that person a lot of fluids to drink, because if the person is vomiting a lot and sweating a lot, we don't want them to suffer from dehydration. So water and fluids are also extremely important. Second stage of hyperthermia happens if the core temperature exceeds 41 degrees Celsius. In that case, the process of thermogenesis once again becomes ineffective and the person will require help. That person is suffering from heat stroke or sunstroke. One of the first signs of heat stroke is very rapid heart rate and very strong pulses. The person may also exhibit psychotic behavior. The next stage is unresponsiveness, and then eventually the person will lose consciousness. And if no help is provided, the person may die. So hyperthermia as well as hypothermia are extremely dangerous conditions and should be treated with great caution. Until next video, goodbye.